Hello, my dear friends. Welcome to Toppscholars. Today we'll be discussing about introduction to atoms and atomic theory. So now, friends, what do we actually mean by matter? We can say that everything that is present around us is matter. That is, matter is anything which has mass, occupies space, and we can perceive it through our senses. But friends, what is this matter made up of? My dear friends, earlier it was thought that matter is made up of 5 elements, and that is water, earth, fire, air, and sky. But friends, later on, Maharishi Kannad proposed that matter is made up of tiny particles which are called as atoms. He said that matter consists of indestructible particles which are called as paramanu, where param means ultimate and anu means particle. These paramanus are now called as atoms. So according to Maharishi Kannad, matter is made up of these indestructible particles which are now called as atoms. According to him, these paramanus do not exist in free state. Rather, they combine with other paramanus to form a bigger particle, which are now called as molecules. Now, friends, later on, an English scientist named John Dalton proposed atomic theory. He said that these tiny particles that make up matter are called as atom. According to Dalton, matter consists of very small indivisible particles called atoms, which means that matter is made up of many atoms, right? So if you look at a drop of water, this drop of water is made up of so many molecules of water. In turn, this drop of water is made up of so many atoms, right? You cannot count the number of atoms that are present in one drop of water. Dalton's atomic theory says that an atom can neither be created nor be destroyed. For example, let's understand the formation of a water molecule. So here you can see we have 2 molecules of hydrogen, right? And we have 1 molecule of oxygen. 1 molecule of hydrogen contains 2 atoms of hydrogen. Similarly, 1 molecule of oxygen contains 2 atoms of oxygen. So what happens here is these 2 molecules of hydrogen react with 1 molecule of oxygen, and what you get over here is 2 molecules of water, which means that atoms cannot be created, neither atoms can be destroyed, right? According to Dalton, atoms of an element are identical in all respects. Let's take an example to understand this, right? So here you can see I have an iron rod, right? Or I can say iron bars, right? Now these iron bars are made up of a single element, and that is nothing but iron, right? Which means that it is made up of many atoms of iron, right? According to Dalton, all the atoms of an element are identical. So here we can see the iron rod or the iron bar is made up of so many atoms of iron, right? And if you pick any of these atoms of iron, you will notice that these atoms of iron have the same size, right? Similarly, if you measure the mass of these iron atoms, it comes out to be the same. So from this we come to know that atoms of an element are identical in all respects, whether it is size, whether it is mass. So this is what Dalton said. He said that atoms of an element are identical in all respects. According to Dalton, atoms of an element combine in small whole numbers to form molecules of that element, right? For example, 1 atom of hydrogen combines with another atom of hydrogen to give you hydrogen molecule. As you can see over here, 2 atoms of hydrogen combine with each other to give you a molecule of hydrogen. Let's take one more example. So here I have an atom of hydrogen, I have an atom of oxygen, I have an atom of hydrogen. Now, as you can see over here, 2 atoms of hydrogen combine with 1 atom of oxygen, giving you a water molecule, right? which contains 2 atoms of hydrogen and 1 atom of oxygen. Dalton said that atoms of one element can combine with atoms of another element in a simple whole number ratio to form molecules of compounds. Let's understand this with some examples, right? So here you can see I have an atom of hydrogen, an atom of oxygen, an atom of carbon and an atom of chlorine. So Dalton said us that atoms of elements combine with atoms of another element in a simple whole number ratio and they form molecules of compounds. So here the first molecule I have is a water molecule, that is H2O. As you can see, a water molecule is made up of 1 atom of oxygen and 2 atoms of hydrogen. So what is the ratio? It is 2:1, which means that we have 2 atoms of hydrogen and 1 atom of oxygen. The next compound we have is CO2, that is carbon dioxide. Now friends, tell me, how many atoms of carbon can you see over here? 1 atom of carbon. How many atoms of oxygen are there? 2 atoms of oxygen. So what is the ratio? 1:2, which is a whole number ratio. The next compound, CH4. Now friends, tell me, what is the number of carbon atom you can see here? 1 carbon atom. And how many hydrogen atoms are there? 4 hydrogen atoms. So what is the ratio? It is 1:4. The next compound, HCl. How many atoms of hydrogen are there? 1 atom of hydrogen. And how many atoms of chlorine can you see here? 1 atom of chlorine. So what is the ratio? It is 1:1. So according to Dalton's atomic theory, atoms of an element combine with atoms of another element in a simple whole number ratio. And what is formed is molecules of compounds. Remember friends, atoms combine in whole number ratio. They do not combine in fractions. Now friends, here we discussed about the important points about Dalton's atomic theory, right? To learn more about this topic, download Toppscholars app.